Hello, good morning, and welcome to the chemistry lecture on the topic gaseous state. In this lecture, we are going to learn how gases are collected over water and the volume of the gas is measured, and that volume is used to calculate number of moles and mass of that gas. Gases which does not dissolve in water are collected over water. So the title I have written here, collecting gases over water. So here the chemical equation is written: zinc dust or zinc granules are taken in solid state in this flask. Here is zinc powder or zinc dust. This is rubber cork, the airtight cork, it is airtight, and this is funnel. This is the cork used to regulate the flow of dilute HCl. In this funnel, aqueous dilute HCl is filled. So HCl, which is in aqueous state, zinc reacts with dilute HCl to produce zinc chloride and hydrogen gas Balance this equation. On right hand side, two chlorine atoms are present. Therefore, on left hand side, take 2 times HCl. Here, the number of hydrogen becomes 2. On right hand also, there are 2 hydrogen atoms. Hydrogen molecule is formed, hydrogen gas is liberated. So, by opening the cork, HCl is added and the hydrogen gas is produced. This hydrogen gas passes through this side tube and enters in a gas collecting tube. This is a beaker containing water. This is gas collecting tube which is completely filled with water and inverted over this outlet of hydrogen. So the hydrogen gas formed passes through this tube and enters in a gas collecting tube. The hydrogen which is liberated is collected by downward displacement of water. Hydrogen enters in this gas collecting tube which is closed at one end and open at the other end. 0 ml is marked at the top and marking progresses towards the bottom. So the collected hydrogen is at the top. The hydrogen which is collected also contains vapors of water. Vapors, water vapors. So, the hydrogen which is collected by downward displacement of water is collected in the upper part of gas collecting tube. The hydrogen which is produced pH2, partial pressure of H2, or the hydrogen gas is a mixture of H2 and vapor of water. The hydrogen partial pressure of hydrogen I represent pH2 and partial pressure of water by pH2. According to Dalton's law of partial pressure, in a mixture of gases, the partial pressure of constituent gases, the sum of partial pressure of constituent gases is equal to total pressure of the gas, is equal to total pressure of the gas. So look here, this is water at 19 degrees centigrade. 19 degrees centigrade is the temperature of water. At 19 degrees centigrade, partial pressure of vapor is 17 mmHg. 17 mmHg. And partial pressure of hydrogen is 752. 752. That is equal to 769. 769. Now you see, volume of hydrogen, it is measured like this, or before that, the hydrogen which is collected is a mixture of hydrogen and water vapor. The sum of partial pressure of hydrogen and partial pressure of water is equal to the total pressure of the mixture, is equal to the total pressure of the mixture. The barometric pressure which is measured is 769 atmosphere, 769 mmHg. So P total is also equal to 769. The barometric pressure is measured like this, or the volume of hydrogen is measured like this. The gas collecting tube is lowered or raised in such a way that the level of water in the tube and in the beaker is the same. The water level is adjusted so that the gas collecting tube, the level of water in gas collecting tube and in beaker must be equal. At this condition, atmospheric pressure becomes, the atmospheric pressure of the gas is recorded. Atmospheric pressure of the gas is recorded. The barometric pressure is found to be 769 mmHg. The barometric pressure is measured by using barometer. One important thing, the gas collecting tube is lowered in such a way that the level of water in the tube and outside the tube is same, and under this condition the volume of the gas is noted. So in this way gas is collected over water. The condition is that hydrogen does not dissolve in water. These two are not dissolved. Hydrogen is not dissolved in water. So this volume of hydrogen which we have measured by using gas collecting tube is used to calculate number of moles of hydrogen and mass of hydrogen. Number of moles of hydrogen and mass of hydrogen. This knowledge is useful to calculate number of moles of gas and mass of gas. So there are problems on this type, and the one problem example is solved in your textbook that I am not going to solve. The exercise 5.11 which is given in your textbook, I am going to solve that problem. So just wait for 1 minute. So welcome back. This is exercise number 5.11. The problem reads like this: oxygen can be prepared by heating potassium chlorate with manganese dioxide MnO2 as a catalyst. The reaction is twice KClO3, which is in solid state, is heated with manganese dioxide catalyst MnO2. It gives twice KCl in solid state, thrice O2 which is in gaseous state. In short, in previous example or in previous theory, we studied hydrogen is prepared by the reaction between zinc and dilute HCl. Here, oxygen is prepared by heating potassium chlorate. The chemical reaction is here. What is asked? How many moles of O2 would be obtained? How many moles of oxygen would be obtained from 1.3 gram KCl potassium chlorate KClO3? If this amount of O2 were collected over water at 23 degrees centigrade and a total pressure of 745 mmHg, what volume would it occupy? So whenever you solve any problem, read the problem carefully, write down the given data. Also write what is we have to find. If the units are different, convert them into required units and then solve problem carefully. So I am going to solve this problem. I write here solution. I remove these 3-4 lines because there is only chemical reaction. So I clean the board first. Now, how many moles of O2 would be obtained. So I write here moles of NO2 is equal to question mark. This is what we have to find out. From 1.300 gram potassium chlorate. So I write mass of KClO3 is equal to 1.3 gram. For our simplicity, I avoid these two zeros, 1.3 gram. If this amount of O2 were collected over water at 23 degrees centigrade, temperature is given in degree centigrade on degree Celsius. We want to convert it into Kelvin. Therefore, I write capital T is equal to 23 plus 273, that is equal to 300 Kelvin. That is equal to 300 Kelvin. And a total pressure of 745 mmHg. So I write P is equal to 745 mmHg. Now you remember, we have to convert this pressure into atmosphere. And again they ask what volume would it occupy? Phi of O2 is equal to question mark, volume of O2. This is the problem which I am going to solve. I clean the board. Pressure exerted by water vapor is called vapor pressure of water. And the values of vapor pressure at different temperature are given in your book. So I write total pressure is equal to, this is our first step, P total is equal to partial pressure of O2 plus partial pressure of H2O. That is vapor pressure of water. We have to calculate pressure of O2, partial pressure of O2, that is equal to total pressure minus partial pressure of water, that is equal to total pressure is 745 mmHg. So I write here that is equal to 745 minus partial pressure of water, the value I have taken from the table given in your textbook, that is equal to 21.1, that is equal to 723.9 mmHg. Now this volume I want to convert into atmosphere, how to convert pressure of O2 is equal to 723.9 into 1 upon 760. 1 upon 760. Number of problems we have solved of this type. How to convert mmHg into atmosphere? The answer is 0.9525 atmosphere. Solve this by using calculator. This is second step. Now, potassium, atomic weight of potassium is equal to 39. Atomic weight of chlorine is equal to 35.5. Atomic weight of oxygen is equal to 16. Is equal to 16. Calculate molecular weight of potassium chlorate KClO3 that is equal to, in potassium chlorate, one atom of potassium, therefore I write 39, one atom of chlorine 35.5 plus 3 atoms of oxygen, that is equal to 16 into 3, 48. That is equal to. Molecular weight of potassium chlorate is equal to 122.5. 122.5. This is the molecular weight. I take nearly about 123. Nearly 123. Now I am going to write one relation and make here two parts. Third step I am going to explain. One 23 gram of KClO3 contains 123, that means molecular weight of KClO3. 123 gram of KClO3 contains how many grams of oxygen? There are 3 atoms of oxygen. 16 into 3, that is equal to 48 gram O2. Gram O2. Therefore, 1.3 gram of KClO3 contains how many grams of O2? 1.3 gram KClO3 is equal to how many grams of O2? It is very simple. Solve it. That is equal to cross multiplication 48 into 1.3 divided by 123. Divided by 123. The answer is, that is equal to 0.508 gram. 5.08 gram. This is third step. Fourth step, this much gram of potassium chlorate oxygen is produced. Oxygen. So calculate now number of moles of oxygen. I write here N of O2. This is we are going to calculate. That is equal to mass of O2 divided by molar mass or molecular weight of O2. That is equal to mass of O2 we have calculated 0.508 divided by molecular weight of O2 32. In O2, 2 atoms of oxygen 16 into 2 32. That is equal to. Solve this. The answer is 0.050. 0.050. This is the moles of oxygen. This is the moles of oxygen. They asked volume of oxygen. Volume of oxygen. You know the relation P into Phi0 is equal to P into Phi0 is equal to P into volume of O2 is equal to N of O2 into RT. PV is equal to nRT. We have to calculate volume of O2. Therefore, take this P on right hand side. On right hand side. That is equal to number of moles 0.015 into R gas constant, value is fixed 0.0821, temperature is given 300 Kelvin, divided by pressure of oxygen, here 0.9525. Simplify this. The answer is 0.3878. The answer is nearly equal to 0.4. The volume is expressed in liter. Nearly equal to 0.4. So these are the problems. There are 3-4 steps in this problem. See the problem, solved problem in your book, and some exercises are also given. Solve those problems. So today I am going to stop here. Thanks for watching. Now in next period we shall see kinetic molecular theory of gases. Thank you so much.